Okay, this is the condensing unit video, but because these are videos, they move a little more organically. We're going to pick up a few spares along the way. So we're going to start off with electrical, because electrical is the first thing inside the electric service and inside your report. And the sealant around some of your exterior boxes, this one isn't so bad, but the sealant around these exterior receptacle outlet boxes should be routinely maintained to help prevent moisture infiltration to the wall systems. And the same thing goes for the electric disconnect, to the condensing unit. We'll move to that. Got off the electrical onto the condensing unit. The condensing unit, the disconnect is over here to the side. It's on the wall. This is a good thing. We have an electric receptacle outlet close to your condensing unit. That's also a good thing. I like to say good things every once in a while. I do. I'm not that evil of a person, hardly. Alright, this is your condensing unit. It's a heat pump system, which is very energy efficient. Some people don't understand heat pump systems wholly, including me. So I've got a white paper baked into your report that explains how a heat pump system works. But basically, this is your heating and your cooling. It's a heat pump system. When we're outside here like this, all we feel is heat. It might be 40 degrees outside, so there's not very much heat and we're cold. It might be 90 degrees outside, there's a lot of heat, we feel that, so that sensation we have is hot. There's no such thing as hot and cold, there's only heat. We don't have a hot thermometer and a cold thermometer. So, when it's 40 degrees outside, we have 40 degrees of heat. This system will actually run in reverse, and it will pull the available heat out and move it into the house. It's very energy efficient. Now, most of the times and most of the ways we relate to these systems is as condensing units for our cooling systems. And it's true, and when it's 90 degrees outside, it pulls the heat out of the house and brings it in here and then distributes it out, moves it to a more desirable location. That's what it does. That's what your refrigerator does. If you unplug your refrigerator, heat goes to cold. It will sit there and it'll collect heat. You plug it back in, it'll start pumping it out, extracting it. And if you put your hand behind your refrigerator, you'll feel that heat to a more desirable location. So this is what this is a condensing unit. It distributes the heat. So it's your heat and your cool. And again, they're very energy efficient. If you're up north, you think gas is high. Why? Because they don't have very much heat. They're pumping gas all the time. Alright, down here we say gas bill's not so bad. Why? Because we don't have very much heat. We hardly run our heaters. Oh. This is only one bill, it's your electric bill, so it's going to seem just a little higher maybe, but you know, when you take in consideration the price of gas and everything else, it turns out that this actually is for a conventional system, this is the most economical system we have. It's true that we have solars, it's true that we have thermal, we have some unconventional systems and windmills. We could use a windmill today, but for conventional heating and cooling systems, a heat pump is your best bet. It really is. And the insulation right here, this insulation might be different than what you're looking for, is because this is what's required now. It's a lot more robust. These are anti-theft Schrader valve caps. That's what we're supposed to have. That's a good thing. The manufacturer says that this is between 14 and 15 SEER. It might even be higher than that, depending on what the condensing unit is. We have some fine print down here. For the purposes of your inspection report, I'm going to put 14 or more. Over here, we're learning this system was manufactured in 2000. We're going on 2022. I'm going to write that it's 2 years old, manufactured 2 years ago. It might have been installed last week. This is a 1-year warranty inspection, so I get that. It's only 1 year. That's what you're seeing. This equipment is engineered on paper to last about 20 years. In this part of the country, it lasts about 14. That's what Las Vegas is going to get. It might last 30, but all bets are on 14. So I'm going to stop on his 14th birthday. I've got an 18-year-old system. I installed it new. But anyway, so it's a new system. It was manufactured about 2 years ago. It's a 4-ton system. It's good to know. The refrigerant is 410A. That's the good stuff. All these things are good things to know. All these things are good things. So, that was the condenser. Oh, that has some bad things. It's not level. It's not level. You have a pot inside there for your condensing unit, which is a scroll, and refrigerant has oil in it, and the oil collects at the bottom of the pot, and then the scroll brings it up to lubricate the system. And when your system is not level like that, okay, then your system's not getting oiled like it should. Another thing is the foundation pad is supposed to elevate the condensing unit a minimum of 3 inches above the ground. Okay, that's all condensing units. At one time, it was just heat pumps, but this is a heat pump. But today, all condensing units, including your heat pump, should be elevated a minimum of 3 inches. We've got a low corner over here where it's not level. This unit should be level. Another thing is this home does not have rain gutters. Okay, so the water just pours right off of the roof. Where does it pour? Right down on top of your condensing unit. Is that good? No, it's not good. Are you supposed to? Yes, you are. You're supposed to have a diverter up there. It could be a rain gutter. A rain gutter would be better, but it could be a diverter, like this kick-out flashing right here. It could be some kind of a diverter to keep the water from coming down and crashing right down on your crooked condensing unit, causing it to age prematurely. So what did we learn? We learned that our unit's not level, and it's not high enough on this corner, and it does not have a rain diverter. That's what we learned. But we're not through yet. Remember, we're catching up some spares here. Okay, we're all about spares. Where did the handle go for this bib faucet? Is this how we turn the water on back here? I'm scared to do this. I shouldn't do it. Oh, I did it. Okay, the water works. I could tell it was. Look how rusty this is. Where did the handle go? Mr. Builder, did you deliver a handle or not? If my client took the handle off, then that's on you. I'm sorry, but you know what? If the house didn't come with a handle, it should have. It sure should have. Okay. Also along in the report, we have water heaters, and after the plumbing is water heaters. We had the electrical, we had the air conditioning, and we had the plumbing. We have the water heaters, and that's the temperature pressure relief valve drain lines, and they're supposed to discharge between 3 and 6 inches from the ground. This is a little iPhone 12 Pro. Hey, and we are 6 inches off the ground, so we're good there. I guess we're good. If I can get out of here safe. I'm kind of trapped. I don't know. That's a kind of precarious place. Your client, you might want to move that. And then farther along, what we have here is this is the rain sensor for your lawn sprinkler system. So we know that you have a rain sprinkler sensor. Okay, and then going on to alternative or optional systems, we have retaining walls. Usually, whoever has the high ground owns the retaining wall. Unless it's a municipal thing, you know, like they're all through the neighborhood, from a cut and fill situation, and then that might be a neighborhood situation, and it might be yours. I don't do surveys, but a rule of thumb, but anyway, you know, a guideline to use is usually whoever has the high ground is responsible for the retaining wall. I'm not saying that, it's out of my wheelhouse. What I can say is that if a retaining wall is farther away from the structure than twice its height, okay, if it's farther than that, okay, twice its height, then in theory this retaining wall should have no effect on the foundation performance. Okay, a lot of people use the 45-degree angle, so if it's farther away from, if it's no closer to the house than that, which is twice its height, funny how math works, okay, geometry maybe, but then in theory it should have no effect on the house's foundation, and therefore this retaining wall and the one on the other side of this structure are beyond the scope of this inspection. If I see something, I'll call it to your attention. I'm nosy like that. I got that from my grandmother on my mother's side. But, you know, in theory, this retaining wall is beyond the scope of this inspection. Crooked condensing unit too low on one corner, no overhang. No handle. We need some sealant over there.